Hello everyone, we're going to go through the 5.3 study guide for environmental science, and I'm going to try to help you out with some of the answers so that you can get it done. The good news is if you watch this video, you're going to be able to get answers to this, and along with this I also have the book up on my screen on my computer so that I can kind of refer you to different pages as well. If you're working through this using your book to help you with the study guide, that can help as well. The plan for this week, by the way, is to get through Chapter 5. We're going to be looking at 5.3 and 5.4. 5.3 is going to focus on ecological communities, and then 5.4 is going to be looking at community stability and how stable a community actually is. Now, we've been kind of working on this all along when we talked about keystone species and when we talk about, things going extinct and how that affects things. So the last two chapters or sections of this chapter are actually going to kind of go together pretty well. So I'm going to go through and look at these. And the first one I see here is primary producer. And a primary producer is an organism. Let's see if I can write this on here. An organism that converts sunlight or chemicals, because there are a few things that don't need sunlight. We'll talk about those in a minute. Into energy. So some examples of this would be plants, right? We have lots of plants. And then there's also things that live in areas that where the sun doesn't shine, so to speak. They live at the bottom of the deep ocean where it's, ink black. There's no sun ever down there. And those are animals, okay, that use what's called chemosynthesis. And I'm going to write that word down here for a minute. Animals that, whoops, it's not going to work. That use something called chemosynthesis. chemosynthesis. Okay, so animals that use chemosynthesis are animals that live at the bottom of the ocean. They live in caves. They live in places where the sun never shines. And so instead of using photosynthesis, they use chemosynthesis. And then, of course, plants use what we call photosynthesis. And photosynthesis basically is taking sunlight and turning it into energy. Okay? So this is taking sunlight, turning it into energy. This is taking chemicals that are in the water or in the caves or wherever they are and turning them into energy. So basically a producer is an organism that converts sunlight or chemicals into energy. Pretty easy to know. Now, photosynthesis is the process in which CO2 plus water, which is H2O, plus sunlight equals energy. Okay? So that's basically photosynthesis. It's when we take carbon dioxide plus water plus some sunlight, and we're going to make energy in the form of sugar. Okay, sugars. And then there's also some O2 that's given off, right? Some O2. So in that case, that's photosynthesis. Chemosynthesis, on the other hand, is totally different. That's where we're going to take carbon dioxide, again. So this is going to be CO2 plus H2O plus, there's other chemicals. So we'll say other energetic chemicals. MICALS, and we're going to convert those into energy. Okay, and that energy is going to be in the form, again, believe it or not, of sugars plus O2. Okay, So even though there's no sun, those creatures that live in those places can still convert things into energy, and that energy is in the form of sugars, and of course the oxygen is given off as a byproduct. So one is called photosynthesis, meaning sun, and one is chemo, meaning chemicals. Okay. We find a lot of chemosynthetic creatures near volcanic vents deep in the ocean. And the reason why is because those volcanic vents are giving off a lot of heat. They give off a lot of sulfur. They give off a lot of acid. They give off a lot of things that those creatures can use to help them convert this CO2 and H2O into energy. Okay. So that's where you're going to find a lot of those chemosynthetic type creatures or producers. The next thing is consumer. A consumer is an organisms that rely on others for its energy. Okay? So we have the producers up here that don't need anyone, right? Those creatures, those living things, don't need us, but we need them. Okay, so plants, things like that, they're going to live on this planet whether there's animals or not. But consumers have to have plants, otherwise we will never go anywhere, right? So in that case, we have consumers or organisms that rely on others for its energy or for their energy. I'm going to move down a little bit here to cellular respiration. Cellular respiration is the process where, where sugars are broken. There we go. I have very bad internet today. Broken. We can't get the O in here. Or broken. There you go. Into CO2 plus H2O. So it looks like this. It's going to be sugar plus O2 yields CO2 plus H2O. Okay? So it's basically the reverse. Do you see how it's the reverse of this? Okay? And so, yeah, these two things work hand in hand together. Cellular respiration is the opposite of photosynthesis. In photosynthesis, we take CO2 and H2O, add a little sunlight in there, and you can make sugars and O2. Over here in cellular respiration, we're going to take the sugars and the O2 and turn it into CO2 and H2O. So it's kind of, you scratch my back, I'll scratch yours. You make sugars, I'll eat them and give you CO2, and here we go back and forth, okay? Kind of cool. Looks like herbivore is already done for you. That's an organism that primarily is going to eat plants, okay? And then a carnivore, that's an organism that primarily eats meat. Okay, we got your meat eaters, your sharp tooth, if you will, okay? So that's those, and now let's move on to the next one. Omnivore. This is an organism that eats both. It eats both plants and meat. Okay? Some omnivore examples, those would be bears, humans, etc., right? There's lots of things that eat both plants and meat, and we're one of those. This next one you may not know. This is called a detritivore, and what in the world is a detritivore? That's an organism that consumes non-living organic matter. Okay, so these are organisms that eat dead stuff. Okay, so this would be, rotting logs. It would be, decomposing animals, those kinds of things. It's going to eat that kind of stuff. It eats detritus, stuff at the bottom. Crayfish are really great for that. That's why I have a lot of crayfish and shrimp in my tanks, because they eat the fish poop. It's great. They can break it on down. They eat old rotting food that's at the bottom of the tank. They keep the tanks clean at the bottom because that's their job. You know, they're the janitors, if you will, of the fish tank for me in my room. Now, on the other hand, we have decomposers. Oh, by the way, another example in your terrariums. What did we put in your terrariums as the detritivores? Do you remember that? I told you to find some springtails. Because the springtails would eat the mold and they would eat all the rotting plant material. And then also, what do we have? We put in roly-polies, didn't we? And those roly-polies, they actually do the same thing. They're detritivores. They eat dead stuff. So, and also in my aquariums, I have the crayfish, and I also have snails, and they also are great detritivores. So now, decomposer. This is an organism that breaks down non-living matter into simpler parts. That breaks down non-living matter into simpler parts. Some examples would be bacteria. Okay, so if I could put that over here, some bacteria, very good at this. Fungus are very good at this as well. So these would be the things that are going to break stuff back down into its principal components, into its individual chemical compounds, okay? So that's a decomposer. The next thing is trophic level, okay? And we're going to be talking a lot about trophic level over this week, okay? This is an organism's rank in the feeding hierarchy. So I'll put down organisms rank in the food chain, I'll say. I'll just say it like that. That might make a little more sense than saying feeding hierarchy, right? And so we have lots of different trophic levels, and we'll be talking about those in more specific detail pretty soon. So biomass, this is the total amount of living tissue in an area. Okay? And so this biomass idea, this is everything in a particular area. So let's talk about a fish tank for a second. In a fish tank, you're going to have pounds and pounds and pounds and pounds of gravel and sand and decorations and water. None of those things are alive, right? But if you took all of the bacteria and all of the fish and all of the crayfish and all of the snails and all of the plants that are alive, and you put them on a scale, that's going to be the total amount of living things that are in a particular tank. Okay, so that would be its measure of biomass. Everything else is going to be abiotic stuff, right? The rocks and things like that, those are not living, and so they are not considered part of the weight of living things that's in a particular area. Now, a food chain is a linear series of feeding relationships. Okay, so it's a linear series of feeding relationships. So, let's see, we have the little fish. Well, let's see, we could just draw it, right? Let me erase this real fast. Maybe we'll do this in like blue. Okay, here we go. So we've got the little fish going this way. So here's the little fish, and here's the bigger fish. He's going to eat this guy. And then we have the way bigger fish, like coming after him. And then, of course, we have the gigantic fish out here. I can't even draw him. Oh, that's terrible. Oh, terrible. Don't do it. I can't draw a big fish, you guys. You are looking at someone who cannot draw. So this would be the really bigger fish. Okay, so he's like, yes, I'm going to eat you. No, and they're all running away. Okay, so that's going to be the, that feeding relationship that we're talking about here. Hopefully you guys can draw better than I can. Food web, this is a map of all the way that energy flows. Okay, so this is a map of energy flow in an ecosystem. So in this case, we just have a chain, right? This is just one into the other, going that way. Well, a map of energy flow is a lot different. That's going to be, let's see, let's put this down on there and maybe do green. This is going to be, hey, we've got this animal here. Here's an animal. And it's going to, go to this animal, which goes to this two animals, which goes to that animal, which comes up here to this animal and that animal. And here's another animal. And here's an animal that goes to this animal. Okay, so it becomes a lot non-linear. This is more of a map of how the energy flows through a system. And we might say that the energy is flowing in this direction, okay? So that's what's going to happen with food web. And then finally, the last one that we're going to look at on this definition is keystone species. So let me erase this that I just did with my finger by accident. Okay, and keystone species, we've talked about this already, haven't we? And now here it is in our vocabulary. This is an organism, an organism, that has strong, or wide reaching impact. Oh, get back. No, come back. I think I hit it with my thumb or something. Impact on a community. And we've seen examples of that, haven't we? We've talked about the wolf and how taking the wolf out of Yellowstone Park really was a bad idea, right? And bringing the wolf back even changed the course of the rivers. Everything changed when we brought back that keystone species. Same thing with the otters. If we take otters out of the kelp forest, then the kelp forest literally disappears because the otter was eating on the sea urchins, which were eating the kelp forest. Well, if the otter's not there to check that sea urchin problem, then, the kelp forest is just going to disappear into oblivion. And then that's going to cause lots of other creatures to not be able to do anything either. And we used a word when we talked about that, and it was called trophic cascade, right? You've heard me say that word many times. And so having these keystone species, they're actually, I don't know, all animals are important, but these particular animals are more important than others. It's kind of a strange situation here. So I'm going to answer these bottom two questions, or three questions, I guess, and then I'm going to stop this video. And then I will make a second video for the next 2 pages, and then you should be good to go for the rest of the study guide, okay? So I'm going to answer these 3, and then we're going to make a second video. Okay, identify the ultimate source of energy for most of the Earth's ecosystems. That's easy. That is the sun, okay? The sun is the source of energy for every time your heart beats, for every time you wiggle and jiggle, for every time you laugh or smile. It is sunlight that you have converted into the emotions and things that you do. Okay, the next one. Why are plants considered primary producers? Because they capture the sun. They capture energy from the sun. The sun for all other living things. Okay, so they are the primary reason why we are able to be here. It is plants, okay? that are the primary producers for us. Even if we never eat plants, we still eat the animals that ate the plants, and so that